Okay, picking it up with the final lecture for this week. So this becomes the current and next evolution. Now we need information storage and data retrieval capabilities. So I love the term logography, right? Where each character represents a word. But there's a better way to do things, I think. So the Greeks made the first alphabet using vowel sounds as well as consonant sounds, and it has 24 letters in it, right? And it transformed the spoken word into written form. Our English language has 26 characters, so very close, right? And so we transfer through a series of phases, right? Various other capabilities were developed over time, including codecs. Gutenberg created the first printing press and newspapers. There's a good description of that in the book, right? Here's a little bit about Guten's printing press and how it begins to transform society in the written word. And it's about storing information, right? Same with newspapers, quite a bit of treatment there. We're getting to this brings us all to hypertext, right? Hypertext, it was an article published in 1945, and it focused on the problem of computers with information retrieval, right? The human mind doesn't index well. It doesn't work that way. So instead, our memories are associative. And so it was suggested that a machine could simulate to some degree the mind's ability to make associations between pieces of information. So the term was coined hypertext. That was coined. And it refers to this linked network of notes containing information. And the system, the first system to utilize this was called Xanadu. It's long since been replaced, I believe. It was a worldwide network of collected or connected literature, right? And the World Wide Web, with its library of files, is the reality that we live in, right? And so we move here to the mother of all demos, right? So now that we've added information storage, we need one more piece, which are these input devices. So the mother of all demos is the name retroactively applied to a computer demo, right? Given it an IEEE, right? Institute of Electrical and Electronics Engineers. They actually set some of our standards to this day, IEEE. So a demo there back in 1968 showed in San Francisco, it showed a live demo of the complete computer hardware and software system. It was called an online system, or more commonly NLS. And it was a 90-minute presentation that had all the fundamental elements back in 1968 of a modern personal computer. It had Windows, hypertext, graphics, right? Efficient navigation and command inputs, video conferencing, and a computer mouse, a word processor, dynamic file linking, revision control, a real-time editor, so it's collaborative, right? And this was called the mother of all demos. Anyhow, very interesting. The underlying technologies here, as a result, influenced both Apple, their Macintosh, and the Microsoft Windows GUI, or graphical user interface, and the operating systems of the 80s and 90s. So the graphical user interface, or GUI, this is where it came from, right? So it springs from this concept of the mother of all demos. And in 1979, Xerox in Palo Alto at their research center developed the first prototype for a GUI. When Steve Jobs saw this prototype, he had an epiphany. Bam! Right? And set out to bring GUI to the public, right? So Apple engineers developed Lisa, which was the first GUI-based computer available to the public. Okay? And the developments continued for the hypertext system as discussed in the literature. So I won't go into that too much more. You can review the literature yourself. but it was a way of connecting peoples across vast areas, right? Well, now that we have all these GUI, the network, the way to transmit packets back and forth, we've got a visual way we can edit. Now we need search engine. So search engine is basically a program that accepts a list of keywords from a user, and it searches its database and returns documents. So there are two types of search engines to be aware of. One is a crawler-based, and Google is a crawler-based search engine. It automatically creates a database of info about web pages, and it's using programs called spiders. And spiders, they follow hyperlinks, and eventually they're visiting millions of different web pages, and they'll summarize these in the info collected to the massive Google database, right? The other type of search engine is a human-built web search engine database. It's more accurate than a spider program, but it takes longer to build, of course, right? Then the final piece, then moving to the final piece of this course, is just a conversation about, well, let's have a definition, right? IT. What is IT? IT refers to the devices used to create, store, manipulate, exchange, and disseminate data. If any of you have had any project management training or you're going into that at the UONA, notice that the definition of IT is very much in agreement with the definition of managed communications process in project management. You may want to look at that and look at the comparisons. And so the issue is this, in information technology, as we get to this point, is making a copy expensive? Yes, the answer is yes. The original copy of something, as Gates would lament ages before, right? That it's not cost effective for him to develop software if people are going to steal it, right? So making the original is expensive, but the copy of the original is inexpensive. And that's really where we're going here with this, right? So we ask, what are reasonable intellectual property rights in the information age? This brings us back to our course, all this history into ethics and law applied, right? Do the laws need to change? How should businesses adapt? That sort of thing. Okay? And so take credit cards, for example. Their use is unbelievably undeniable. I'm not sure if that makes sense. I hope so. It is. They're fabulous, right? But if stolen, they can be, we agree, I think, decidedly inconvenient, right? They also, credit cards raise privacy concerns. Who has the info about my spending patterns? Who has the right to that information, right? So the use of IT has changed the way even banks process loans. It used to come in, get an interview, present your business proposal. That's no longer the case. Today, banks consult a national credit bureau, right? And there are other issues to be aware of, right? Such as software issues that may have resulted in injury or even death, right? If there was a software issue in a driving program, for example. So when the computer bugs do harms to humans, who should be responsible, right? What about the workplace, right? How does monitoring our work affect us in the workplace? Does it create an unacceptable level of stress? What about the software companies doing business in developing their software in countries with low salaries and maybe harsh working conditions, right? Even working from home has disadvantages, I think we would agree. So we want to continue to consider these and various other aspects as we seek to determine once and for all, is technology driving us, or are we driving technology? Thank you very much. This concludes the lectures for week 1. Enjoy the reading, the discussion, and everything else we're working on together. And I look forward to working with you in the following weeks.